Hi, welcome to Supermatics Online Math YouTube channel again today. Today's math tutorial is about the areas of special triangles. In this tutorial, we want to show how to derive the formula for calculating the areas of these special triangles and also solve a couple of examples on the calculations of these areas. So sit back, relax, and enjoy it to the very end. The first of these special triangles that we shall be considering is isosceles triangle. Now, let us call this isosceles triangle ABC. And in an isosceles triangle, two sides are equal. So let us call the equal sides the side A, while the base side, which is different, we call it side B. What we are going to do next is to draw the altitude AN. Now the altitude AN divides the base B into two equal halves. So we have BN to the B over 2. And we're going to call the altitude H, which is also the height of the triangle. Now to determine the area from triangle ABN and by Pythagoras theorem, we have that H squared is equal to A squared minus B over 2 all squared. That is, H squared is going to be A squared minus B squared over 4, making the altitude H to be the square root of A squared minus B squared over 4. Now that the altitude has been obtained, recall that the area of triangles generally is half multiplying the base length multiplying the height. That is the altitude. So the area in the case of this isosceles triangle is half times the base length, which is B, times the altitude, which is the square root of A squared minus B squared over 4. This means that the area of isosceles triangles is B over 2 times the square root of A squared minus B squared over 4, where A is the equal side and B is the base side. Note that this further simplifies to B over 4 times the square root of 4A squared minus B squared. The two give the same result. Now we're going to apply this in an example to show how to use it to calculate the area of an isosceles triangle. To find the area of this isosceles triangle, the equal sides A, 10 centimeters, while the base side B is 8 centimeters. From what we just derived, the area is B over 2 times the square root of A squared minus B squared over 4. This means that for this isosceles triangle, the area is 8 over 2 times the square root of 10 squared minus 8 squared over 4, all in centimeters squared. And that is going to be 4 times the square root of 100 minus the square of 8 is 64, and 64 divided by 4 is 16. Meaning that this is 4 times the square root of 84. And 84 is 4 times 21, so the square root of 4 is 2, making the area to become 2 times 4, which is 8 root 21 centimeters squared. This may also be written if the square root of 21 is obtained as 36.7 centimeters squared to 3 significant figures. If you are yet to subscribe to this channel, click on the subscribe button now and hit the notification bell so that you don't miss out on any of our updates and our math tutorials. Now let us continue to the next special triangle. The next is equilateral triangle when the three sides of it are given. And do not forget that all the sides of an equilateral triangle are equal. So we're going to call this triangle ABC. And the sides we call side S units. There are three of them. Another thing to note is that each interior angle is 60 degrees. So as at before, we draw the altitude. Again, the altitude divides the side into S over 2 units, while we call the altitude H, and let the altitude meet the base side at N. So again, from triangle ABN, using trigonometry this time around, we have that tan 60 degrees is H divided by S over 2. That is, tan 60 degrees is 2H over S. But tan 60 degrees is root 3. So we have root 3 to be equal to 2H over S. And making the altitude the subject of the formula, we have H to be equal to root 3 over 2 times S. Again, we shall be using the formula area is half times the base length times the height. So in this case, the area is going to be the product of half times the base length, which is S, and the height is root 3 over 2 times S. This becomes root 3 over 4 times S squared. This is the formula for calculating the area of an equilateral triangle when the side is known. Applying it in an example, we want to find the area of an equilateral triangle where the side is 6 centimeters. Again, the area, as we just found out, is root 3 over 4 times S squared. So in this case, the area is root 3 over 4 times 6 centimeters squared, which is root 3 over 4 times 36 centimeters squared. And that is 9 root 3 centimeters squared as the area of the equilateral triangle. And this to three significant figures is 15.6 centimeters squared. This is an equilateral triangle in which the altitude is known. Again, we still call it triangle ABC with the altitude meeting it at N. So as before, the sides S and BN here is S over 2. So what we shall be doing here basically is to find a representation for the side. So from triangle ABN, as at other times, tan 60 degrees is H over S divided by 2, such that we have root 3 to be equal to 2H over S. And this implies that the side as subject of the formula is 2H over root 3. So that the area in this case becomes half times base. The base is S, which is 2H over root 3, and the height, which is H, the altitude, giving H squared over root 3 as the area, which may also be written as root 3 over 3 times H squared. This is the formula to calculate the area of an equilateral triangle when the altitude is known. Now let us put this to practice. We want to find the area of an equilateral triangle given an altitude H of 6 root 3 centimeters. The area in this case as derived is root 3 over 3 times H squared. So in this case, the area is root 3 over 3 times 6 root 3 centimeters all squared. And that is going to be root 3 over 3 times The square of 6 is 36 and the square of root 3 is 3 centimeters squared. And this gives 36 root 3 centimeters squared as the area, or to three significant figures, it's approximately equal to 62.4 centimeters squared. We believe after watching this tutorial, you should be able to calculate the area of isosceles triangles, equilateral triangles, 1 given its size and 2 given its altitude. Leave your questions, comments and thoughts in the comment box and we will surely respond to them. Do not forget to subscribe to this channel and visit more often as we have exciting tutorials in the channel and many more are still on the way. Bye.